All right. For this problem, we are going to sketch the region enclosed by the given curves, and then we're going to find the area. Now, what we need to know is that this is a down-facing parabola. It's a quadratic. The x squared term has a negative in front. That's why it's facing down. And the other one is an upward-facing parabola. Up-facing, upward-facing. I think I should get my act together and make that into an adverb, or maybe. Okay, anyway. I'm not sure. Okay. So essentially, we're looking for something like this. All right, that's what we're looking for, roughly speaking. Now, by the way, it depends where you are sitting around on your parabola world of how much you remember about parabolas, but this is y equals negative x squared plus 12. And the standard form for a parabola is y equals ax minus h squared plus k, and the vertex is hk. So see, because it's in this form, we can write the vertex pretty easily, that this is looking at y equals negative x squared plus 12. This is x minus 0 squared. So the h is 0. That's that first coordinate of the vertex. And then plus 12 gives the second coordinate of the vertex. And we can do it, pretty quickly, a standard, do something on this other parabola, x squared minus 6. The vertex is 0 because we have x minus 0 squared. And then the y coordinate, 8k, will be negative 6. Okay, and then beyond that, let's find the intersection points. So for our intersection, we equate these two. 12 minus x squared equals x squared minus 6. I'd say I need a lot more space to get this problem going here properly. I need way more space. Okay, so what I'm going to do is I'm going to put the numbers on one side. It's easier for me to add 6 to both sides, I think, and get 18, and then add x squared to both sides. So I have 2x squared equals 18, x squared equals 9, x equals plus or minus 3. So the thing is, I have the graph paper, which sort of makes me feel like I need to draw a good picture. And gosh, but look, I'm going to shift up by 12. That's a lot of paper, but I could do it. But let me just put this next problem on the next page. Okay, so the question is, am I going to go the whole way here and do a really good picture here? The vertex is 212. See, I don't think I have enough space, except I can switch to smaller paper. Let's see if I do that. Let's do it. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that gives me 0, 12, and the other one is down by 6. 1, 2, 3, 4, 5, 6. All right. Otherwise, these parabolas, y equals x squared is something we've sketched a lot, and so these parabolas are, just regular old parabolas. They've just been y equals x squared. I mean by regular old parabola, it's just been shifted up or down. And so, if you think about y, look at this x squared minus 6. But if you look at x squared, the way the parabola works is from the vertex y equals x squared. If you go to the right by 1, you go up by 1. If you go to the right by 2, you go up by 2. So if I stick with that idea, anyway, I don't know, whatever. Okay, when x is 3, let's just even find the y coordinate. But you don't have to be so careful. But When x is 3, I have, for y equals x squared minus 6, when x is 3, I get 3 squared minus 6 is 3. So my point of intersection is going to be 3, 3. All right. I'm just getting carried away on this, really. It's just sort of over the top. You don't have to be that precise at all. I mean, at the very beginning, I said, okay, you know, upward facing, downward facing parabola, you know, that's basically the only thing that I really actually, I think that was essential is that I find those points of intersection. Otherwise, you didn't have to find the y coordinates. I just start, you know, I just get involved. I just start thinking, okay, I'll just draw a better and better picture. Okay, this looks like maybe it's a whale's mouth right before we're eaten. Right before we get eaten, there's the whale's mouth. Man, imagine being swallowed by a whale. That'd be something. I don't even know if that really happens. Do they really get swallowed by people? Okay. On the bottom is y equals x squared minus 6. On the top, y equals 12 minus x squared. Here's, we have the x-axis and the y-axis. I'm definitely using more paper than I really needed to. But it's, you know, it's free because I have this, you know, what's the big deal? Okay. So the area, okay, now the area, sorry, I keep zooming in and out, but the area is going to be the integral from A to B of the top minus the bottom. And I mean the top, the function on the top minus the function on the bottom. And also, I think we were supposed to draw a rectangle. So if you do draw one of these little rectangles, well, the one thing that's noticeable is that the thickness of that is dx. That, no. Okay. It's out of control. Okay, sorry. X squared minus 6. Okay, so the thickness of this rectangle is important for us to know. That's dx. The thickness of dx. All right. So what's our functions on the we're going from -3 to 3. We look at x values. On the top is 12 minus x squared. On the bottom is x squared minus 6 dx. Now the thing is, I'm going to use symmetry. Some people are like, why would you do that? Because it's going to make it easier. I'm just going to find the area of the part to the right. The blending of these two colors is sort of, I don't know, it's a little bit strange color I'm getting there. Okay, I don't know, strange, muddy looking. Looks a little bit muddy. All right. But anyway, I'm going to find the area. I'm just going to go from 0 to 3. I'm going to get the integral from 0 to 3, and I'm going to double it. It's going to be easier to put in 0. And then I'll simplify this. 12 minus -6 is 18. Negative x squared minus negative x squared is negative 2x squared dx. And I have 18x minus 2x to the third over 3. I plug in 0, 3. When I plug in 0, there's nothing there. It's just 0. So I'll have 18 times 3 minus 2/3, 2 to the third power. So I'll have 18 times 3 is 54, minus 2 times 8 is 16 over 3. And I think if I had thought about, there's probably a more clever way to do this. Let me at least factor out 2. So I'll get 2 times 2, 27 minus 8/3. I have a feeling, I hope I'm not doing this wrong. I think I am though. Anybody want to speak up? Maybe not. There's, okay. Sort of just want to look. Why doesn't someone look at the back of the book while I'm chatting here? 3 times 27 is 81. So it's 81 over 3. It's not that bad. It's going to be 4. 81 minus 8 is 73, right? I don't know. I don't remember seeing that answer. So I feel like stepping over and um, and getting the book. Anybody have an answer in the back of the book? Following along? I have to walk over to the other side of the room to get the book and look it up. I have a feeling that's not it. So let's not ruin the video. Let's just find if there is a mistake, or maybe not. Oh gosh. Okay. All right. I have the book, opening up to number 13. And the answer is that's not right. So this is number 13. And the answer is 72. But that's not it. Oh, gosh darn it. Okay, I'm just going to keep going. I'm not going to throw away the video, I guess. I mean, everything's correct, right? So it's just at the very end, I must have made a mistake. 3 times. So I guess. Oh, gosh darn it. It's right here. Look at this. Why doesn't someone speak up? Okay, it's x is 3, so it's 3 to the third divided by, much easier. 3 to the third divided by 3 is 9. All right, sorry everyone. That's not good. We were talking about maybe I need to retire soon and take a job directing traffic in the parking lot of Disneyland instead of teaching math. Okay, and maybe this isn't right. Okay, 54 minus 18. So that's 2 times, oh no, okay, I'm getting sort of flustered. 44 minus 8 is 36 and 72. Okay, sorry that I made that mistake, but there we go. Got to plug in the numbers properly. It's putting in 3, I put in 2. Any questions? Anything you want to talk about? Someone last time I suggested I might quit teaching and work at the parking lot. They said, hey, no, the parking lot's pretty good at Disneyland. Okay, so, all right, maybe I'll see you all over there instead of in math class.